Hi everyone, my name is Grigory Trofimov. Today we're going to talk about AI innovations for software test automation. If you'd like to participate in today's presentation, please submit your questions to the question area and we will address those questions at the end of the presentation today. We should have some time for Q&A. With that being said, let's go ahead and get started. 2021 is a pretty exciting time for artificial intelligence. There's been a lot of progress made in various areas of this particular practice, of this particular technology, but it's definitely not perfect. So for me, a good way to sort of characterize the state of AI in 2021 is kind of the robot vacuum cleaners or Roombas, if you're familiar with those. They're very good at what they do. They clean the floor. They're able to pick up dust and pet hairs and maybe pet food and things like that. They actually map out the room pretty well and sort of adjust to furniture. And AI has been really good in that sense. So when you look at things like self-driving, when you look at targeted advertising or Siri, Alexa, etc., there's a lot of good coming from the way AI is being introduced into the world and really kind of leaving that sort of sci-fi world and making its way into the mainstream. And that's really the good side of AI. On the other hand, you can't really still rely on AI exclusively, right? So Roombas can't really handle stairs very well, or I mean, maybe they can now, but last I've seen, they tend to sort of fall over the stairs, or if their sensors get blocked, they kind of get themselves into trouble. Similarly, if you use your Roomba to pick up some jelly or some pudding on the floor, it actually makes things a lot worse, right? It's going to spread it all over the floor, and now you actually have to clean up much more of a mess than you had initially, right? So AI is kind of in a similar place in 2021. On one hand, you have extremely powerful processors and computer chips, and you have the World Wide Web and quantum computing, all these things that really enable AI to be powerful and very helpful in our day-to-day lives. On the other hand, you kind of have to think about, what is the right application of AI? Should we be using AI here? Things like facial recognition, deepfakes, etc. That being said, obviously Roombas and vacuum robotic vacuums aren't necessarily the pinnacle of AI either, right? So the bar for what we consider good artificial intelligence really kind of has been raised in the last few decades, right? So in the past, things like um, optical character recognition were considered state of the art artificial intelligence. Then the ability to have a conversation through questions and answers was really considered AI, being able to fool people to think that machines were humans. And that's really elevated here, right? So now, if we look at the broad definition of AI, it's a broad discipline that covers anything related to making machines smart, exposed through ability of a computer program or machine to think and learn for itself. I like to simplify this definition a little bit, right? So AI, the guiding principle of AI is being to take an input and process that input and return output the result in a fashion that a human does not recognize that it was a machine that did it, right? So basically, do things like a human would, and a human shouldn't be able to tell the difference that that it wasn't a human that did it. And that can be a little tricky because we humans, we're always changing the rules, right? I mean, even for AI, like we're always raising the bar, we're always redefining things, we're always adjusting to changes, we're always adapting to our environment. So us humans, we have this intrinsic drive to always change things, to always move things around. And so for AI to do that, it needs to be able to learn, it needs to be able to look around, figure out its the surroundings, and act as a human would. Now, humans, we never do the same thing twice the same way. Machines can actually do that, and they will do that if told otherwise. And that's where machine learning comes in, being able to absorb data, absorb and learn from experience, absorb historical context in order to improve its behavior or adapt its behavior to the current situation and current conditions. Now, mentioned, a lot of progress in the last 20 years or so. Deep learning has really kind of taken that machine learning concept to the next level, since we're now able to process much larger data sets with all the technology that we have. And we also have much larger data sets because of the World Wide Web, right? We're able to produce a lot more data for our machine models and for our machine learning uh, to to really be effective. And then there's neural networks, right? So this refers to a model of human neural networks that are designed to help computers acquire new knowledge and to reason intelligently. Now, today's presentation really focuses on AI and software testing, right? So, what are some of the key capabilities? What are some key innovations that we've kind of defined here that we can leverage for software testing? Well, in software testing, we're always trying to shift left, right? So the ability of AI to do things like a human is definitely going to help us because we can do things like a human, but faster. It's going to help us reduce human error. It's also going to enable, uh, us to leverage human intelligence in other areas of the SDLC, perhaps, in areas where we don't necessarily need a repetitive task to be done in such a fashion. That's going to help us increase efficiency. It's going to help us decrease costs, being able to shuffle things around that way. Uh, AI can learn over time and identify patterns. This is going to help us create better tests, right? The ability to sort of survey the systems, learn from those systems, understand paths and how different services integrate and work with each other is going to simplify our test flows. It's going to reduce the time it takes to create tests and automate tests. And then, of course, the adapt to change part, being able to adapt to its environment, right? So in in modern agile software development, we're always changing the application. We're always changing features. We're always changing functionalities, and that's really where a lot of headaches come from. Is having to either manually test those changes or having to uh, deal with those changes late in the SDLC. Uh, AI can help us there by speeding up validation and uh, sort of unblocking those release cycles, right? Making those release cycles a little bit smoother and not delaying the releases due to, well, as we'll see, broken tests. But the question is, do we really need AI in software testing? I mean, these are great capabilities, but you know, we have the testing pyramid, right? And the testing pyramid really is a very effective and efficient, scalable test automation strategy. We have static code analysis, so we know our code is written uh, securely and reliably. Our developers have unit tests uh, that validate individual functions and methods. We have component testing and integration testing at the API level, which is taking care of some of the common flows and regression testing and smoke testing and so on and so forth. And then, of course, we have all these UI tests that we wrote in Selenium that are doing UAT validation for us, which leaves us with just the incremental changes to test manually at the end of release. And we have all these great tools that are going to help us automate those tests uh, for the future sprint, right? So where can we, where do we need AI here? Well, if we take a look at our UI tests, you know, tests tend to fail, and they fail for various reasons. At the UI level, one common reason is broken element locators, or maybe the application changed in some way and the tests are not broken. So there's not really a defect in the application itself, but the tests themselves are broken. Not to mention, it took about 10 hours to run all 2,000, 3,000 of my tests, and because of the 200 that are broken, I'm now having to delay my release and then have to rerun those tests once those tests are actually fixed. But that's okay, right? I mean, we have API tests, so maybe we can automate some of those UI tests, convert them into API tests. But we don't really know how those APIs work, right? I mean, once we open up the application, there's some unique calls that aren't documented in our Swagger definition files. Additionally, there are some API calls that require some kind of token or some header values that we're not truly familiar with, and we're not sure where we're getting those from. And actually, part of this application that we're testing is a packaged application from another provider. So we don't even have access inside those APIs to really automate those in such a way. But that's okay because our developers are writing unit tests, right? So they're validating those components at the function level, at the method level. Um, Unfortunately, due to deadlines, the developers didn't have that much time to write meaningful tests. So we got some code coverage, but we didn't get all of it. And then there's also the 3 million lines of code that is actually legacy code, and we haven't really touched that in about 10 years. So we do have some unit tests, but not a lot of unit tests there. But that's okay. I mean, we have static analysis, so we know our code is written reliably and securely because we're running static analysis on all of that whole code base. Well, even though we're running static analysis, we get like 10,000 violations. So, we're still trying to comb through those violations. We're still trying to figure out which one of those we should prioritize to fix first. So, that being said, obviously, if we can automate testing, if we can leverage the testing pyramid to shift left, we've done a very good job. But uh, agile development really requires you to do this continuously and to do this at a very fast pace. And this exposes some challenges in terms of adopting test automation. And these are challenges that we can leverage AI and principles of AI to help us mediate them. So let's start at the bottom of the pyramid there with static analysis. If you look at the common static analysis workflow, right, you run static analysis as a part of your CI/CD, and all of those violations, all of those rules that you've enabled to take a look at your code, gets published into some single reporting location, right? In Parasoft, that's Parasoft DTP, and that's great. Now, at this point, someone like a technical architect, or maybe a team lead, or maybe a team of developers, really have to comb through those violations and figure out which of those violations need to be prioritized, which of those violations need to be suppressed, which of those violations maybe need to be disabled. The rules themselves need to be disabled, and maybe that's not a rule that we want to run against our code base. This is really where we can start leveraging AI. We can take a look at those violations, and we can establish a historical pattern or some historical context as to how we're divvying up those violations and how we're prioritizing those violations. And then when we look at that over time, we can start to see that there's actually clusters of violations, and we can predict with fairly good reliability based on those clusters how to treat those or how to categorize those violations, whether they should be suppressions, whether they should be prioritized, etc. Parasoft DTP allows you to do that. It allows you to train an AI model to prioritize violations. There's actually a number of algorithms that you can choose when you're prioritizing those violations. And the end goal is, of course, to get quality action items or get quality tasks back to the developer as quickly as possible, so they can actually fix those violations for the next iteration. Now, if you're interested in finding out more about how we leverage AI in Parasoft DTP for static analysis and security, please check out our resources at the end of this webinar. We have some very good information there. We've done some very good webinars specifically on that topic as well. So please do take a look at that. Moving up the testing pyramid, we have unit testing, right? And we talked a little bit about the legacy code, but we typically see organizations kind of struggle in three areas when adopting unit testing. Of course, the first one is the legacy code, right? The elephant in the room. Uh, Typically, it's code that's not maybe the team's not even really that familiar with. There's really not a lot of stake in wanting to refactor that code or actually even fix the code, which is kind of interesting. If you're unit testing it, then why are you unit testing if you're really not going to fix that code? But nevertheless, there's a mandate across the organization to get to 50, 60, 70% code coverage, right? And we don't care how you do it, just do it. So at that point, you're kind of finding yourself in a bit of a hole there, and AI can really help you there by generating unit tests for large code bases, right? Being able to comb through, you know, 50, 60 classes, 100 classes, generate unit tests, not just any unit test, but meaningful unit tests that you can then go back and you can expand on and maybe enhance in some way, just to get you that baseline, to get you that 50, 60% that's mandated uh, by your boss. But also do it in a way that's actually somewhat maintainable, right? So that you can actually go back and either add new unit tests or maybe change some of the ways that those unit tests behave. What's really key here is to do some sort of analysis on that code while those unit tests are being generated, right? So generating execution flows, maybe figuring out how some of those unit tests need to be initialized, what type of assertions need to be created for those unit tests. Those are all key functionalities that you're looking for when you're looking to leverage AI to generate unit tests for legacy code bases. On the other hand, when there's rapid development, when there's new implementations, typically deadlines and deliverables will take priority over testing. So in this instance, the developers will write some unit tests, but are they meaningful unit tests? And really, how much time is being spent on writing those unit tests? So here we can really kind of optimize that workflow because AI can help us do things like a human would, right? So a unit test solution here, unit test assistant, essentially would generate human legible code, right? Human legible code that maybe isn't using any proprietary libraries or injecting any dependencies that kind of leave you with code that can't be that isn't very maintainable or can't really be moved around. It also guides in some way, right? It actually gives you some feedback in a way that maybe helps you either improve the code itself or improve your tests or help you cover uncovered lines or expose maybe some flows that aren't currently covered by your existing unit tests. Those are all things AI can really help you with there. And of course, the third point is you want to avoid falling behind, right? So the burden of maintenance, if your code changes, if the business logic of your code changes, which tests need to be updated? At the same time, maybe you might have tests that actually modify the behavior of the application or put it in a certain state. So you want to be able to detect that prior to executing your tests as a part of your CI/CD, so that you're not wondering why is this test failing as a part of my CI/CD, but it's passing locally. AI can help there, right? AI can detect those changes. It can map, based on the code to test relationship, which tests are affected by those changes, which lines of code are touched by which tests, right? You don't necessarily have a one-to-one relationship between a function or a method and a unit test. You may have unit tests, all across your test class that are exercising a specific line of code. So knowing which tests have been affected will help you minimize the amount of tests you need to run to fix those tests, and it'll also help in the maintenance in the long term. Here we have our Parasoft Unit Test Assistant, which is a part of Parasoft JTest. We're leveraging common frameworks, open source frameworks like Mockito, PowerMock, JUnit, Spring. You can install the Unit Test Assistant directly into the IDE as a developer. That could be your Eclipse IDE, your IntelliJ IDE, and really enables you to save 50, 60, 70% of the time associated with writing unit tests. So This kind of brings us to our API testing and automated UI testing. And we'll talk about these sort of somewhat together. We'll start from the very top here from the UI test, but you might notice that the challenges of automating UI tests and creating API tests are somewhat similar. So we can maybe tackle some of those problems together. But let's go ahead and start at the top here. Okay, and there we go. So what are the common UI testing challenges? So we did a survey of our webinar attendees and trade shows, and almost 50% unanimously said, building tests that are maintainable over time is difficult to do when doing UI testing, right? If you're using Selenium, essentially writing that Selenium code, writing those Selenium script in a way that's maintainable, in a way that it's adaptable to dynamic applications, can be a difficult thing to do. If you kind of look at the rest of these results, they're really along the same lines, right? Is that applications change, UIs are dynamic, element locators are dynamic, weight conditions are dynamic, and all these things really impact the execution of your automated test cases. And writing test cases in a way that's adaptive to those changes can be a very difficult thing to do. So this is where we're gonna actually switch perspectives from our PowerPoint presentation to a technical demonstration. And I'll go ahead and share my screen here. Okay. And so this is really where our journey begins, right? How can we leverage AI to do something that a human would in a similar way that a human would? And if I'm testing and if I have a requirement, right, to validate some component of my application, this application here is Parabank, our demo application that we use here. One thing I might want to do is I might want to record my manual test case and try to convert this manual test case into a UI test, and frankly an API test as well. So we have the Parasoft recorder. This is an extension for Google Chrome. If I go ahead and start recording here, it's going to start capturing all the UI actions within my browser. So I can go ahead and log in. We'll give it a second here. And while it's logging in, there it is. Okay. So go ahead and logged in. We have some basic functionality that we can execute here within Parabank. For example, we can pay some bills. So maybe that's my requirement, right? Is to validate the bill pay functionality of my Parabank application. So we'll fill in this data here, provide some account number, verify the account number, submit payment. There it is. And it looks like our bill payment was complete. If we go ahead and log out here, we've completed our test case, and we can go ahead and stop recording. So the first thing that we're seeing here is the UI actions that were captured in the browser, right? This is the UI portion of our test automation journey here. We'll go ahead and give this test a name. We can actually associate this test with a work item, right? Maybe there's a requirement here that we can add, perhaps a Jira work item or maybe a work item URL that we can associate with this particular test. And then at this point, we can go ahead and say download recording. The second portion is the API traffic. We actually also monitored the network and we've recorded some API traffic from this test. And we can reuse the same metadata to tag this particular test case. And we're going to go ahead and say create test here for now, create test asset, and then we'll take a look at what at that a little bit later. But first things first, let's take a look at our UI test. If we want to go ahead and add that UI test into, convert it into a Selenium test, let's go ahead and just select our recording. We store that in a JSON file. We'll give this test a name, and we'll fill in, give it a package name. Let's call it Burbank Class. Go ahead and hit finish. And that's pretty much it, right? So that actually creates the Selenium test for me. It's in human legible format, so it's just like a human would have wrote it. We have our before test setup. We have the after method. We're actually adding some key options to Chrome, right? Some common things like starting the browser in incognito, disable, enabling strict powerful feature restrictions, maximized windows, all those typical things that you might want to do in the context of your Selenium test. But more importantly, we're actually creating this test using the page object model, which makes these tests inherently much more maintainable. If we're looking to update or modify any of our element locators, uh, for various reasons, maybe they were updated or maybe some values changed somewhere, we don't have to search through our test to find every single instance where we're referring to that particular element locator. We can navigate to our page object model to uh, to make that change there. Let's go ahead and run this test here. No, we're actually not leveraging any proprietary uh, Parasoft libraries or anything like that in this test. This is all based on uh, open source libraries. So in this case, we're using TestNG. As you can see, the test uh, ran successfully. But the common problem that we have is, well, what happens when the application changes? What happens when my element locators get updated or maybe weight conditions change? Well, luckily, I actually have a second version of my Paramake application. We can run this. We can run our test against and see whether or not this test will pass. Additionally, if I'm actually running these tests as a part of my CI/CD process, I may want to I want this test to try to fix itself in some way, right? Perform self healing or adapt to the changes, and we can do that with Selenic, right? We can actually perform self healing during the execution. We'll also go ahead and generate a report at the end, and hopefully we can get some recommendations on how we can enhance our existing UI test to make it smarter and more resistant to change. So that being said, let's go ahead and launch our test. And while the test is running here, we can actually monitor the console output, because what we might see here is the test breaking in some place, but also attempting to fix itself. Okay, so here we're logging in. Looks like our accounts overview actually looks a little different. Our bill payment looks a little bit different. And as you can see, we're actually, the Selenic agent is telling us something here. And what it's telling us is that a locator name pay phone number actually failed. So self-healing was initiated, and there was an element, a replacement locator that was identified and implemented instead. And if we take a look at the report, that's actually exactly what this report is telling us, right? Is that the test didn't necessarily pass, it didn't necessarily fail, but it was in fact healed during runtime. And if we take a look at where it actually failed, it failed on this phone number element, right? So able to type in the zip code, but then couldn't find a phone number. And then if we drill into this report, we can actually see that that although it wasn't able to use this element locator using the name strategy, it was able to find a CSS alternative. And it's given us a confidence factor of how confident our model is that this new element locator will work over and over in future iterations of our application. So having that historical context enables us to do some sort of analysis to learn from previous executions and adjust our model to provide better recommendations as far as maintainability of your UI tests. If we navigate back to the IDE, we're actually we get a recommendation here from Selenic, so that feedback is coming directly to the test developer to say, hey, there's some element locators here. You might want to go ahead and update them. And if we go ahead and take a look at the options, they are very similar options to basically what we were provided in our report, along with our confidence factor, our model weight, and our stability indicators. If I go ahead and click update, it's actually going to go directly into the page object model and update that one location where that test needs to needs to be updated for a more maintainable test that shouldn't fail when we see changes in our application under test. So to summarize, Parasoft Selenic enables us to capture, record manual test cases. We're using the page object model to create Selenium tests. Those tests can be self-healed during runtime, during your CI/CD execution, and provide recommendations back to the developer to enhance the uh, the test, and provide reporting into our centralized reporting system and for additional traceability with our requirements. Now, if we take a look at API testing, it's a different set of challenges, right? So we know why API testing is good, right? It's quicker to execute. It's a little bit more targeted in terms of component testing. It's a little bit easier to diagnose, your defects when you do find that your tests are failing. But the challenge is, it's really difficult to take that requirement defined at the user level and melt that down into API calls, especially without explicit domain knowledge of those services and how those services all work and interact with each other. This is where we're actually able to leverage our API traffic, right? So during our manual test, we did capture some API traffic, and so we do know what those API calls are. But how can we take all that traffic and, in an intelligent way, create an API test with minimal work? Well, let's go ahead and change perspectives again. And this time we are in a different workspace. We are now looking in Parasoft SOA test. And in SOA test, I have my workspace. I have my test cases here, and I actually have a new test case here called bill pay. If this seems familiar, this is actually our test case that we recorded during the execution of our test. Now, there's a lot of traffic that we probably captured. There was probably images. There's probably some other API calls, maybe some Google Analytics or something like that floating around. But we were able to basically filter out all of those unnecessary API calls and give us the right API calls that we need to actually test our application. Not only that, we are doing a lot of stuff in the background to actually set up this test to make it a runnable automated test. For example, we're setting up validations, right? We're setting up diffs to make sure that when we do run this test, we're validating on things like the account balances and account types. We're also parameterizing values from one API call to another, right? We're able to grab things like our customer ID or account ID and pass that down subsequently in our future API calls. So from test 2 to test 3, we're actually passing an account ID. And this is nice because if I actually want to data drive this test and rerun the same test with a different set of usernames and password, it's already pre-configured for me, and it's already ready to go with validations and parameterizations needed to make this API test successful. Not only that, if we actually want to enhance this test and maybe validate on some additional values, maybe we want something a little bit more granular and we want to validate on this amount. If we go ahead and augment this test with additional tools, like let's say a JSON asserter here, and once it's configured, we realize every single time I record this test, I actually want this asserter to be added automatically. Well, we can actually train our model. We can go back and we can train the brain, as we like to refer to it, to train that test model and to detect that, hey, whenever you see these resources, whenever you see these patterns here, make sure to go ahead and add a JSON asserter to the following API call. If we take a look at these test templates now, we can actually see the rules that are being implemented when we're creating these tests. Not only that, we can then reuse these tests for performance testing. So if we can go ahead and launch our load test application here, these exact same tests can then be ran with 10 virtual users, 20 virtual users, 30 virtual users for for however long it takes to really validate your application and make sure that it's performing as expected with the expected load. On that note, let's go ahead and there. So if we just go ahead and actually import one of our SOA test projects, one of our AI generated tests. Let's just grab the same test that we just recorded. We can now define scenarios, right? We can now define scenarios for a number of users. We might want to do a bell-shaped curve test against our application to determine, how it behaves at certain peaks or how it ramps up during usage times. We can also maybe do more of a soak test, right? And perform a steady load against our application and validate that it behaves a certain way once we start bombarding it with additional API calls. We could also test the limits and the boundaries of our application and do a linear increase test until the application eventually fails, and to find out what those thresholds are. So just by being able to record manual test cases, we're able to translate those manual test cases using AI just like a human would, and learn from that traffic how our application behaves, what the necessary API calls are. Similar workflow, right, as to what we kind of saw with Parasoft Selenic. Record manual test case, use AI to build API test scenarios, import those tests into SOA test. So we're able to reduce wasted cycles, fail builds due to unstable UI test environments by leveraging self-healing for UI test automation. We're able to reduce the time spent maintaining and repairing Brill UI tests, leveraging the AI's inherent ability to do things like a human would.
We're able to reduce the complexity and domain knowledge required for API testing by being able to parse that traffic and look at that traffic and stitch together those API calls and make all the necessary parameterizations that we need. We can actually also streamline the test maintenance based on analysis of contract changes. So reusing those definition files to map and refactor those changes from version 1 to version 2, which we'll actually talk a little bit more about in detail here. But with that being said, let's go ahead and now shift our focus a little bit to the CI/CD side of things. Now that we've been able to automate out all our tests and our builds and build out our test automation pipeline, it's really time to optimize it, right? So in rapid agile development, it is important to be able to shorten cycles and provide developers and testers with meaningful feedback when things change and when changes are introduced into code. Specifically, having a robust test automation pipeline enables us to gather consistent data and feed our model with various types of metrics like number of test executions and corresponding coverage, which in turn enables the holy grail, which is essentially this test impact analysis, right? And there's 3 basic steps in this workflow that we want to understand. One is figuring out what each test covers, right? This is where we establish a correlation between test and code coverage. Once we have that, and we can do number 2, which is understanding the changes from build 1 to build 2, like the lines of code that changed, which modules might have changed, what packages, etc. This is critical to optimizing the test automation pipeline. And then from that, we can figure out what changed and which tests correlate to the code that has undergone those changes. And we can target those tests and only run those affected by changes. Not only will this dramatically reduce the number of tests needed to run to identify defects, but this also establishes a direct correlation between requirements, the code, and the corresponding test coverage. So how do we do all that? Well, let's shift gears here to Parasoft DTP. This is our reporting management and analytics platform with all these wonderful widgets. You can see things here like code coverage, being able to diff build one to build two. I mean, really overall a comprehensive snapshot of quality, you could say, in a historical context. And we can look at things like modified code coverage here, right? So we have this bookstore DB Java class with 15 lines of modified code, and 15 of those lines are not covered, right? So we've introduced changes into our application, but we're not testing. We don't have any tests associated with those changes. These are all things we can deduce from having all that data. We can also drill a little bit further and evaluate risky code changes, right? So understanding what further changes may introduce risk into our application. So for example, we drill into this access mode controller.java class, we can see that there's a high risk associated with changes. The maintainability index is rather low. There's only 7 tests associated with 24 methods for a total of 15% code coverage. And so, there's a good chance that if we do start making changes to any of those 24 methods, those changes will not be covered. This is based on the metrics we've been able to collect, from our test automation, from our builds, that this particular module, this access mode controller Java class, does not have sufficient coverage, does not have sufficient tests associated with it. So to reiterate, along our testing pyramid, as far as UI tests go, AI and machine learning recommendations and self-healing Selenium tests, we can do that to reduce the maintenance and test instability associated with those UI tests. That's our Smart Selenium testing offering. With Smart API Test Generator, we're able to leverage AI and machine learning to stitch together API tests and understand how that API works based on the traffic. We can leverage our JUnit and C and C++ unit testing capabilities to drive code coverage on legacy code and newly developed code, as well as help with the maintenance of that unit test code. And we can leverage our security and compliance solutions to develop models for being able to prioritize and suppress and figure out how to fix and how to address the large amount of violations within your application to improve the reliability and security of your code. In summary, AI provides extensive benefits to software testing, right? We can increase efficiency and productivity by being able to do being able to do things that humans would generally do, but being able to drive that from an automated perspective. We can lower costs and test time by adapting to changes and learning from our existing test automation. We can streamline our test executions to optimize change management and many more capabilities. If you've enjoyed today's presentation, please check out parasoft.com for some additional resources. There you can take a look at our Parasoft brochures, take a look at our blog with many fantastic articles on this topic as well as other topics, and check out our analyst reports to see how Parasoft leads this this space in terms of innovation and application from a application quality perspective. So with that being said, let's take a look at some of the questions we got here today. First question here, what kind of AI does Parasoft use in static analysis? Great question. So what we're allowing or we're enabling teams to do is actually pick their own algorithms, pick their own models when it comes down to analyzing static analysis violations, right? You have tons of violations, but there are patterns, right? And there's clusters of violations that can be identified. And so based on historical context, based on how those violations have been addressed in the past, Parasoft DTP will actually recommend different types of algorithms and different types of models that you can train in order to get the best correlation match based on that history, based on that historical context to those static analysis violations. Another question here, can AI be used for environment stability? Yes, absolutely. So, service virtualization is a very powerful tool here to use for environment stability, being able to stand up virtual services in your environment to remove some of those external dependencies, third-party dependencies, internal dependencies, etc. And absolutely, AI can be leveraged there. So a very common way to develop those virtual services is to do what's called record and playback, right? Capturing some behavior, capturing some data over a proxy, and using that traffic to create virtual services. Well, just like we're able to use the traffic to create API tests, we can actually use that traffic to create virtual services, right? And establish what are called intelligent correlations. These correlations are basically rules of behavior for the virtual services. Figuring out what kind of response we should serve up for a particular request, whether or not a user ID is correlated to a specific set of data. Those things can be all very difficult to configure, but AI and intelligent correlations really simplify that process and kind of give you a great starting point when it comes down to developing these virtual services. Okay, last question here, since we're running out of time. Where do you see the future of AI in testing going next? Great question. Wherever it goes, Parasoft will be step in step with it, right? We'll continue to leverage AI principles and AI technologies and algorithms in our solution stack. If I had to guess, things like chaos testing obviously look very interesting. So that could be a very good application of AI in general test practice. Probably in terms of software development, automated defect remediation. So automating, maybe fixing some of those either static analysis violations or unit test failures, depending on what those could be and how complex are those. But in that sense, you always have to, again, keep in mind that Roomba analogy, right? When is it the right time to leverage AI? You don't want to wind up with a scenario where you kind of have to fix more than you would have if you had just done things manually. And frankly, as long as there's humans writing code and consuming code, there'll always be some need for human validation and verification, right? We can't 100% switch to AI only, but I do see, and here at Parasoft, we believe that in the future, we'll be getting closer and closer to that end goal. So with that being said, thank you very much for attending. Again, please feel free to check out parasoft.com for additional resources. And thank you for your time.